Today, we're going to decode a really fascinating story, one that's literally written in our own blood. We're talking about sickle cell trait. It's an incredible tale of survival, of risk, and most importantly, a distinction that could really impact your health. So let's just jump right in with a bit of a puzzle. What could a deadly parasite and our very own DNA possibly have in common? Well, the answer connects one of history's biggest killers, malaria, with a genetic trait that's way more common than you might think. And this connection, it sets the stage for a pretty amazing story about human evolution playing out right before our eyes. Okay, so to really get a handle on sickle cell trait, we gotta go back in time. We're talking about places like sub-Saharan Africa, where for thousands and thousands of years, this tiny parasite has been a massive force of nature. I mean, it's been so powerful that it's actually shaped our own evolution. And it turns out, in these places where malaria was everywhere, a specific genetic mutation became a powerful shield. This mutation, the very one that causes sickle hemoglobin, gave people a huge survival advantage against malaria. Now, this wasn't just some random fluke. It's a textbook example of something called heterozygote advantage. So, heterozygote advantage, what does that even mean? It sounds complicated, but it's actually pretty simple. All it means is that in places where malaria was a constant threat, inheriting just one copy of this particular gene gave you a major survival benefit. You were just flat out more likely to survive a malaria infection than someone who had two normal copies of the gene. It was a real evolutionary edge. So how does this genetic shield actually work? What's the mechanism here? What's pretty cool. The malaria parasite, it has a really tough time growing inside red blood cells that have sickle hemoglobin. The cell's environment becomes totally hostile to it. And on top of that, the body's immune system, especially the spleen, gets way better at spotting and destroying these infected cells. It basically just stops the parasite's life cycle dead in its tracks. All right, let's zoom in a bit. Let's see how all this works at the molecular level. And to do that, we need to talk about the protein that's right at the heart of this entire story, hemoglobin. You can think of hemoglobin as the essential protein in our red blood cells. It's like the oxygen delivery truck for your whole body. But here's the wild part. Just a tiny change in its genetic code, literally a single point mutation that swaps one amino acid for another, that's all it takes to create the sickle cell version, which we call hemoglobin S. And just look at the difference here. It's pretty dramatic, right? Normal red blood cells are these nice, flexible little discs. They can easily squeeze through even the tiniest blood vessels. But when you put them under stress, like low oxygen, the cells with sickle hemoglobin totally change. They become rigid and get stuck in this crescent or sickle shape. And that shape is the whole problem, because it's what can cause dangerous blockages in your blood flow. Okay, now we're getting to what might be the single most important part of this whole explainer. We absolutely have to understand the difference between carrying the sickle cell trait and having sickle cell disease. I can't stress this enough. They are not the same thing at all. And really, it all just comes down to basic genetics. There's this gene called the beta-globin gene. It's what helps make hemoglobin. You get one copy from your mom, one copy from your dad. And that's it. Whether you end up with the trait, the disease, or neither one, it all depends on which combination of those two genes you get. So what are the odds? Let's break it down. If two parents both carry the trait, meaning they're both AS, then for every child they have, there's a 25% chance of having sickle cell disease, that's SS. There's a 50% chance of just having the trait, like them, so AS. And there's a 25% chance of having neither, which is AA. The big takeaway here is super simple. Trait means you have one sickle gene. Disease means you have two. And this comparison right here is absolutely key. Let's look at the trait side first. Your genotype is AS. Your red blood cells have a mix of normal and sickle hemoglobin. Because of that mix, they mostly stay round, you're usually asymptomatic, and you can expect a normal lifespan. Now look at the disease side. Totally different story. Your genotype is SS. Almost all of your hemoglobin is the sickle type, and that leads to serious problems like chronic anemia, incredibly painful crises, and unfortunately, a reduced life expectancy. Okay, so we've been saying that the trait is mostly a benign thing, right? A carrier state. But, and this is a big but, there are some very specific, very rare situations where it can actually pose serious health risks. And it is so important that you know what these are. And this quote here from the US Department of Defense really sets the stage perfectly. It says, hey, sickle cell trait is generally a benign carrier condition. So for most people, most of the time, you're fine. But then it adds this really crucial part, that in rare instances, when you're under extremes of exertion, there's an increased risk.
So what exactly happens in those extreme situations? So we're talking about rare but really serious risks, and they're usually triggered by extreme conditions. Think severe dehydration, being at high altitudes, or the kind of intense physical stress that elite athletes or military recruits go through. In those moments, the trait can unfortunately lead to some very dangerous complications. Things like muscle breakdown, kidney damage, or even in the worst cases, sudden death. And that's exactly why places like the military have screening programs. It's not because they think the trait is a disease, they don't. It's because they need to manage that small but very serious risk for people who are operating in these incredibly demanding environments.
Yeah, and it's pretty much the same story in the world of high-performance sports. After some really tragic incidents, the NCAA actually brought in mandatory screening for its athletes. And the whole goal here is just awareness. It allows athletes and their trainers to take simple precautions, making sure they're super hydrated, taking time to acclimate to new conditions, all just to stay safe.
So what does all this boil down to? What's the big takeaway? It's this. Knowing your status is absolutely critical, and not just for your own health, but for family planning too.
First off, let's get one thing straight. This is not some rare condition we're talking about. We're talking about an estimated 300 million people worldwide. I mean, it affects a huge number of people, especially if your ancestry traces back to places where malaria is, or used to be, a big problem.
And right here in the United States, it's especially common among African Americans. We're talking about roughly 1 in 10 people having the trait. That makes awareness a massive public health issue. And here's the kicker. A lot of people who have the trait have absolutely no idea. So what if you find out you have the trait? What should you know? Here are the most important things to remember. Number 1, you are a healthy carrier. You're not sick. Number 2, the trait can never turn into sickle cell disease. And number 3, because it's inherited, it does have implications for your kids. And that's why talking to a genetic counselor is such an important step. So is it a genetic shield or a hidden vulnerability? At the end of the day, it's both. It's this incredibly powerful shield that evolution created, one that saved countless lives from malaria. But it's also a hidden vulnerability, one that you just need to be aware of in certain extreme situations. It's just a totally fascinating example of evolution's trade-offs, and a powerful reminder that the story of our health, well, it's written deep, deep down in our genes.